In this video, I'm trying to show you how to calculate the limit on the resolution using the FandPLimitTool. So again, I'm going to double click the FandPLimitTool. Takes a few seconds until it loads. Now, since I'm interested in the resolution limit, I just go to this part. As you can see, from here to here, we have all the localization accuracies, 2D and 3D. From this part onwards, we have the resolution accuracy, first 2D and then 3D. Now, assume that I am interested in 2D resolution accuracy, Gaussian symmetric model pixelated with Poisson noise. So I'm just going to pick this scenario. Okay. So this is the required parameters window. We could enter the parameters that we need. We just change a few parameters in here. We assume that the exposure time is 1 second. We have 1000 photons, magnification is 100. I'm going to increase the ROI size a little bit, let's say 11 or maybe 13 by 13, just to make it large enough. And also assume that we have 100 photons. Okay, I just auto center. Now if you notice, we have two different objects because the resolution problem, so we have two different point sources. And I set the parameters for the first point source. The green ones are I guess common for both objects, but the black parameters are not common, so we need to set them independently. I just hit object 2. I do the same thing. I do 1000 photons in here and 100 background photons, and everything else remains the same, I think. Okay, so now I would like to vary a parameter. That parameter I want to be d. D is the distance between the two point sources, and then look at the localization accuracy as a function of d. So I just pick d in here. And right now we assume that it's 0.5 microns. I'm going to start from 0.1 microns all the way to 1 micron. So 0.1 to 1 microns. And I hit this, check this box, which auto centers the image for each calculation. Okay. Right now there's no results because no calculation is performed and we cannot plot anything yet. So what I'm going to do, I just hit this calculate limits of accuracy button. It takes a few seconds until it calculates everything. Okay, now I can plot the results. I just plot the limit of accuracy of SX versus D. Or I could do, let's say, D versus D, or any of those that I am interested in. So these are the results, but we can also simulate data and model images. Now I'll try to simulate data images. Notice that we have 10 different models, each of which corresponds to one of the distances. D is the distance between the two point sources. And so we have 10 different models. I would like to simulate 15 images per model. So I'm going to put 15 in there. So these are the results. As you can see, if I change this slider, I'm changing it to D. And the point sources are getting separated from each other, which is very obvious. This slider changes the realization, so we see different noisy images of the same model image. So this is pretty useful because very common in many applications to calculate the limit on the resolution when we have two point sources with different separations. Now I can also calculate the model image if I want to, and it just gives me different model images and there is no noise. I can just look at them. Okay, so one important feature that this software package has, as we mentioned earlier, we could export results and parameters, model and data images, and even a LaTeX report. So this first part gives me all the parameters that I use and all the results in a text format. The other one exports the model and data images so we can look at them in another software package. And this is a LaTeX report which puts everything together and creates a nice report that you could save finally as a PDF file. But now I would like to export all of those. So just click this